Okay, continuing with our problems involving surface area and volume of solid figures, we have here the frustum of a cone. So Sandra wants to know the volume of a chocolated candy that she bought from Makati sari-sari store in shape of a frustum of a cone. So it kind of looks like what do you call those flat tops? Okay, candies that has flat tops on them. So given the dimensions of the candy on the image on the left, find the value of x, the radius of the bigger circle, so that's denoted as big R, and the radius of the smaller circle, so that's denoted as small r, and the height of the candy, and the volume of the frustum of the cone, which is the volume of the frustum of the cone is given. It's 1,500 cubic centimeters. So we want to know the two radius, okay, the height and the surface area of the entire frustum of the cone. Before we get to the surface area, first we need to find the volume, and it's already been given. Okay, so it's 1,500 cubic centimeters. So we're going to use this volume in order to find the value of x for the different side measurements here. For the big R, for the small r, and the h. So that's going to be 1,500 times 1/3 pi, and the value of h is going to be 3x plus 9. Okay, again, this is the formula for the volume of a frustum of a cone multiplied by this trinomial. Okay, so that's going to be capital R squared, so that's going to be 2x plus 2 squared. Okay, and then plus, okay, so that's the big radius, so that's 2x plus 2 times the small radius, which is 3x minus 1. Okay, and then plus the square of the small radius, which is 3x minus 1. Okay, so let's try to evaluate these algebraic expressions. Okay, so very easy. Okay, so that will give you 1/3 pi times 3x, so you get pi x, and 1/3 pi times 9, you get 3 pi. Okay, and then we have 2x plus 2 squared, so that's a binomial that's been squared, so that's 4x squared plus 8x plus 4. And then 2x plus 2 times 3x minus 1, you get 6x squared plus 4x minus 2. And then 3x minus 1 squared, so that's a binomial again, square binomial, 9x squared minus 6x plus 1. So you have similar terms here, so that's 4 plus 6 plus 9, so you get 19x squared. And then we have 8 plus 4, so you get 12x, and then minus 6x, so you get minus 6x, and then plus 4, then minus 2, that will be 2, and then plus 1, you get plus 3. And then you multiply this trinomial to the binomial here, that's pi x times pi x plus 3 pi, okay? And if you multiply that, the answer is going to be, okay, so if you multiply this binomial, pi x plus 3 pi, to this trinomial, 19x squared minus 6x plus 3, you get a cubic equation, and cubic algebraic expression, 19 pi x cubed plus 63 pi x squared plus 21 pi x plus 9 pi, and then you have 1,500 here. Okay, so you want to equate that to 0, so we're going to transfer that 1 to the other side, so that's going to be 1,500. And therefore, we have a equation that we can try to find the roots of. Okay, so we can find the free roots of this cubic equation, so this is going to be x sub 1, x sub 2, and x sub 3. And using again the steps, that I've shown you guys, or I taught you guys when finding the roots of a cubic or a quadratic equation, okay, using a calculator, a scientific calculator. So the cubic roots are, okay, so the free roots are 2.04, that's the first root, and the second and the third root are complex roots, negative 2.67 plus or minus 2.21i, or an imaginary number. Since again our roots cannot be imaginary numbers or complex roots or negative, okay, so we cannot consider these two solutions. Okay, so our only solution for this problem for the value of x is 2.04. And from here we can substitute the value of 2.04 to our different dimensions of the frustum of a cone. So we have r is equal to 3x minus 1. Okay, so after finding the value of x, we have these values, so the small r, the large r, and the h, and we just simply have to substitute the value of x for 3x minus 1 for small r, 3x plus 9 for h, and 2x plus 2 for big R. And from there, we get the values: 5.12 centimeters for small r, 15.12 centimeters for the h, and 6.07 for big R. And then we substitute these values to the surface area formula that we have in order to solve for the surface area of the frustum of the cone, or the chocolate candy that that Sandra has, a girl. Okay, so it wasn't stated if Sandra was a boy or a girl. Okay, so big R is going to be 6.07 plus R. Okay, so that's plus 5.12. And then we multiply that to the square root. Okay, so if you notice, this will be the lateral surface area, or our LSA. Okay, and this will be our BA, base area. Okay, so this is for the bottom part because it has the big R, and this one is for the upper part, or the top part, because it has a small r. Okay, so that's going to be big R, which is 6.07 minus 5.12. Okay, and then you have to square that, and then we have to square the value of the height, which is 15.12. Okay, 15.12 squared, and then you have to add pi times r squared, which is 6.07 squared, and then you also have to add the circumference of the upper circle here, so that's going to be pi times 5.12 squared. Okay, so all of this will equal to, if you use your calculator wisely, it will equal to, okay, so the surface area of the frustum of a cone will be equal to 587.31 centimeters squared, or squared centimeters. So we solve for the surface area, the radius of the bigger circle, the smaller circle, the height, and also the value of x, which is equal to 2.04. Okay, so next we have a frustum of a pyramid problem. So Jojo wants to know the surface area and the volume of a flag holder in the shape of a frustum of a pyramid. So the flag holder is in the shape of a frustum of a pyramid. The area of the upper base, or a sub 1, is half of the area of a sub 2. Okay, so that means a sub 1, or twice. Okay, so that means twice a sub 1 is equal to a sub 2. Okay, and the height of the frustum is equal to 75 centimeters. The upper and lower bases are a shape of a square, so we know that a sub 1 and a sub 2 are squares. Okay, so a sub 1 and a sub 2 are squares, so that means the formula for finding their areas are both s squared. Okay. And then, okay, so what else do we have here? So one side of the upper base, so this one a sub 1 measures t plus 4 centimeters. Okay, so this one measures t plus 4, and the lower part measures t plus 12. Okay, t plus 12. Okay, so the area and the perimeter of the upper base, okay, so this is only for the upper base. So the upper base, the area of this one is equal to 50 centimeters squared, and the perimeter is equal to 36 centimeters. Okay, so find the value. Okay, so find the value of t. Okay, we need to find the value of t, the area of the lower base, and the surface area of the volume of the flag holder. Okay, so what we can do here is we have our givens. Okay, so we have here a sub 1. A sub 1 is our first given here. So a sub 1, okay, is equal to the area of the square upper base is 50 centimeters squared. Okay, now we know that the formula for finding the area of a square, since a sub 1, or since the upper base of the flag holder is a square, is equal to s squared. Therefore, we can substitute the value of the side measurement for the upper base, which is t plus 4. Okay, so if the side measurement for the upper base is t plus 4, we can substitute that for the formula here for a sub 1. So that's going to be 50 is equal to t plus 4 squared. Okay, so very simple. And from here we can solve for the value of t. Okay, so if we square this binomial, t plus 4 squared, you get t squared plus 8t plus 16. And if you transfer 50 to the other side or transpose, you'll get 0. To solve for the root of t for the value of t, so t squared, 0 is equal to t squared plus 8t. Okay, so plus 16 minus 50, that we're going to get minus 34. And then again, you can use your calculator to find the roots, okay, of our problem here, or scientific calculator. Okay, now, so we found that the value of t is equal to 3.07. Now we need to find the measurement of the slant height for the trapezoid. Okay, so this is solving for the surface area. Okay, so the slant height is equal to 2t. Okay, so the slant height is just going to be simply 2 times 3.07. Okay, and 2 times 3.07, you'll get 6.14 centimeters. So this is the slant height. Okay, so we're completing our variables and our givens here. Okay, so we're given here that t is equal to 3.07 as we solve, and we need to find one of the side measurements of a sub 1 and then the side measurement of a sub 2, the square. So that will be t plus 4 and t plus 12. So if you add 3.07 to 4, you get 7.07 centimeters. So that's your b sub 1 for the trapezoid formula that we're going to use later. And then for a sub 2, you have t plus 12, so that's going to be 3.07 plus 12. So you're given, so you will have 15.07 centimeters, and that will be your b sub 2 for the trapezoid formula that we're going to use later. Now we're given here a very important given. Okay, so we have here what was that? It says here the half of the area of the lower base. Okay, so that means a sub 1 is the half of the area of the lower base, which means that a sub 1, okay, should be, okay, half of a sub 2. So that means a sub 2 must be 100 and a sub 1 must be 50. Okay, because it's been given here that the upper base, a sub 1, is equal to 50 centimeters. Okay, so that's going to be, okay, so a sub 1 will be 50 and a sub 2 will be 100. Okay, so those will be our base areas. Okay, so those will be our base area in solving for the surface area of the frustum of a pyramid. And then we need to find the lateral surface area. Now, if you notice, the lateral surface area of the frustum of the pyramid of the flag holder are trapezoids. Okay, so there are 4 regular or congruent trapezoids here, and we already solved for the slant height. Okay, so that's the slant height is equal to S is equal to 6.14 centimeters, the slant height. And now we need to find the b sub 1, okay, the b sub 1 and the b sub 2 in our formula. And we already solved for that. That's the side measurement of the square, of the upper base square, so that's 7.07 plus, okay, 7.07 plus the side measurement of the lower base square, the bigger one, which is 15.07. And then we multiply that to 6.14 over 2, okay, and then we multiply this to 4 in order to get the lateral surface area of our figure here, and that will be equal to, okay, so the lateral surface area will be equal to 271.88 centimeters squared if we evaluate this term that we have here. And then we have to add the base areas, okay, for the top and the bottom square figures that we have here. Okay, so that's going to give you plus 150, okay, to get the total surface area. The total surface area of the frustum of the pyramid is equal to 421.88 centimeters squared. Okay, now solving for the volume, okay, solving for the volume, we have this formula. The formula for finding the volume of the frustum of a pyramid is equal to 1/3 h times the area of the top part and the bottom part plus the square root of their products. Okay, so to get that, we have 1/3 and then our h. So the h is equal to 75 centimeters. This is different from the slant height, okay? So this is the entire height, okay, the entire height of the frustum of the pyramid, which is 75. So this is not to scale, okay? Times 50. Okay, 50 plus 100, so this is the area of the upper and the lower bases, plus the square root of the product of the upper and the lower bases, and that will be equal to, so the volume of the frustum of the pyramid is equal to 5,517.77